Okay, welcome back. So we've learnt two different sorts of notations. We've learnt to write relations, and we've also learnt to write functions. So let's go through these. So a relation, the general sort of form, well, you have to give it some sort of name. So let's imagine you're calling it T, and it's the set of ordered pairs, x, y, such that, then here you put in your rule, and then comma, and then you write your restrictions. So they could be domain restrictions, most likely. Domain restrictions. And then you end off your set. So for example, you could say that T is equal to the set of ordered pairs, such that y is equal to x plus 1, for x being an element of all of the real numbers. Okay, so there's a possible relation. And functions, however, the general form of a function is the name of the function, so let's say f, and function f is such that now we put in our domain, and it gets mapped to the subdomain, comma, and then we put in our rule. But our rule always looks like f of x equals stuff. That's our rule, and it's different to this rule, which is always got y's and x's in it. So an example for a function, an equivalent example for this relation is the function. Now because the domain here is R, it's R, and it'll be mapped to the subdomain of R as well. And our rule is f of x, the function of x, is equal to x plus 1. Okay, now you see that these are actually going to yield the exact same result. These are both the same. The only difference is that here we've used a y, and here we've used f of x, so function of x. So something goes in, and something comes out, and that's x plus 1 is coming out there. So what is the difference between a relation and a function? Why don't we just use one or the other? Why do we bother with both? And the answer is that relations are more general. Relations are more general, but functions are actually probably more useful. More useful in application. So functions are actually more common, if you like. It's more common for us to use functions, and we'll basically be using functions for the rest of this course. But relations are more general, and there are some things that you can have that are relations that you can't have as functions. So let's show you one of those. So here we've got, I'll call this relation S, and it's the set of ordered pairs x, y, such that x squared plus y squared equals 1. And I'm going to say that x can be any real number again. Now, what this looks like, the only places where x squared plus y squared equals 1 actually looks like this. It's the equation or the rule of a circle. So here at this point you've got x being 1, y being 0. So 1 squared plus 0 squared equals 1. Over here you've got a similar thing, but here it's 0 squared plus 1 squared equals 1. And you've got the same thing. You can choose any point and you'll find that the rule does actually work. Now, the question here is, why does this not work for a function? Well, let's try. For the function, and we've got real numbers again, mapping to real numbers. Now we try to write the rule. It has to be a function of x, so some input yields some sort of output. So in other words, we've got to rearrange this rule, the x squared plus y squared equals 1, so that this is, so it's in the form of y equals something, and then we can replace the y with a function of x. Okay, so let's see what happens when we try and do that. So we'll put x squared onto the other side by subtracting x squared from both sides. So then we'll be left with y squared equals 1 minus x squared. Now we'll take the square root, so it's y equals the square root of 1 minus x squared. Now, if we were to plot the square root of 1 minus x squared, we actually end up with this. We only end up with half our circle, here. So and that's because, of the nature of this square root function here. So this is a big. This is the reason why relations are more general, because you can have a circle as a relation, but you can't have a circle written as a function. So to finish this off, it'll be f(x) square root of 1 minus x squared. And now they're not the same. This one's a circle, this one's just a semicircle. So basically, for you to be able to write a relation as a function, you need to be able to rearrange it as y equals something or other. And if you want to be able to tell if something is a function or not, if a relation is a function or not, there's a very, very simple test called the vertical line test. So basically, for something to be a function, every x, it has to be, there's an easy test which is the vertical line test. So if you put a vertical line through this relation, the circle, it's possible that it will cut through at 2 points. Whereas if you put a vertical line through this one, it'll only cut through at 1 point. So if it only cuts through at one spot, that means it is a function. In other words, for every x value, there's only one y value. So, for every x value, there's only one y value. So here, for this x value here, there's only this value here. But over here, for this x value, there's two y values. Okay, so you need to remember that, that definition of a function. Alright, that's it for now. See you later.